Right. Good afternoon. Good afternoon, guys. Good afternoon, guys. Welcome to my Zoom session for quantity surveying. Yes. Now I've got a drawing here. This drawing, you'll find it on page 6. Page 6 of this book, Measure and Building Works, by Mr. Fanny Bass. He's a professor that has just recently retired from the DQS department here at NMU. This is his manual. So the exercise is on this book. It's on page 6. Drawings are on page 6. And then you also have your detailed floor plan on page 7. You've got your site plan on page 6. As you can see, the site has got trees to be removed, smaller trees, you've got hedges. Yeah, so what do you do when you are given a drawing? Okay, you are doing quantity surveying 1. So first of all, the need for you to do collects, because that's a chapter you are currently doing now. Collects, you are doing collects so that it can assist you in doing taking off. Yesterday I did do a video explaining the reason we do collects, and the crux of the matter is that you will find that when measuring an element, say foundations, say excavations, say footings, walls, you might end up using similar dimensions in your calculations. So what we do when we do collections or collects is to gather the information, add up all the dimensions that we need in order to do our calculations so that we can reuse it later. Okay, so I'll send you this drawing, but I think you can do a screenshot if you don't have if I don't have your details on the computer. Let me just try to autofocus here. Yeah, I think you can take a screenshot, but I'd like to read for you what Professor Bass says in terms of why you need to do collects. This is the section that shows your elevations for this drawing. So it's got your footings, it's got your floors, it's got your heights for your superstructure, and it's got your depths for your excavations. And one particular thing you will notice on this drawing, we've got levels. Okay? Now this should not scare you, as you are also doing site surveying. This should not scare you, because you've got a level here, finished floor level, and you've got a level here that is natural ground level. You just subtract this one from this one, and then you get the difference that will give you the height to ground level. So don't be intimidated by when you look at like levels and think that it's something to be scared about. So maybe this gives you a better view. So that's a level 99625. That's a level, and then here's this one 100,000. So that's a level. This level, deduct this, you'll get the difference, the height over here. to ground level, finished floor level to ground level. Okay, guys. So I would like you to familiarize yourself. I will send to your class rep this drawing, which has got your site clearance, and then I'll also send him the floor plan, which has got 3 types of walls: a 110 wall, 230 wall, and a 270 cavity wall. Okay, that's fine. Just wanna give you just a background, just a footnote of what Professor Rice says in terms of collects. He says, note on collections. Collections are used to determine the total length of certain items. The total length of these collections are then used in measuring instead of rewriting all dimensions of the items. So that's what I was trying to say, that you collect all the data and you calculate all the meters or dimensions that you will use in different items, so that you don't need to, let's say for instance, you're calculating for your perimeter, for the perimeter of your external wall. Most likely you will need that perimeter to calculate say other things like your DPC. Your DPC goes all along your perimeter length, and then maybe you would need it also to calculate say your footing, so it's a common measurement that is spread through different items of work. So let's continue. The total length of 270 wall will be calculated, and this total will then be used in items with same dimensions. Example: excavations, risk of collapse, concrete footings, brickwork, damp-proof costs. Yes. So that's what I'm trying to say to you, is that it's almost like doing a side cast calculation, so that you calculate all the dimensions you're gonna have to use, so that you don't have to recalculate them. So that's the basic need for doing collections. Okay. This book is a prescribed book, so I would try to impress on you that you should get this book for yourself, so that you can practice your collects, guys. Okay, let's move on from that. Let's come to the exercise. Okay, this is a basic method of doing your taking off. I'm sure all of you guys are now familiar with your dimension paper and how it's structured. I think you'll just drop me a WhatsApp if you think you do not know, you need more info on it. Okay, now let's go. First of all, when you are doing calculations, when you are given a drawing, you need to analyze the drawing first, and you need to check what instructions are given on your drawing, and you need to note any other additional information. For instance, if they say to you the site is already clear, then obviously you won't need to measure site clearance. Your lecturers most of the time might give you almost like a trick in your test or in your exercise, and give you a drawing with trees, and then they tell you no, don't. They give you a footnote saying don't calculate the site clearance because it's already clear. So you must read all of the notes in your drawing, guys. So for instance, if you come to this site plan, already you can see you've got a hedge, you've got some trees, you've got a big tree there, you've got a small tree there. All of these need to be removed, right? So these are the things you need to note. They can also just say to you, just clear around the footprint of the proposed house. So basically, you just need to allow for working space around your footprint of your house. Okay, guys. So let's go to the calculation. As students of quantity surveying, you need to keep it at the back of your mind that your duty as a quantity surveyor, you need to describe to the contractor okay, you need to describe to the contractor what is required by the architect. So the reason you guys are doing construction technology is for you to be able to interpret drawings. You need to be able to read a drawing. You need to be able to see what the architect is trying to say to you, and you need to translate that into words and give an instruction, clear instruction to the contractor. Contractor, this is what the client wants. Remember, guys, the architect in most cases becomes the principal agent, becomes the representative of the employer. So when they speak, they are speaking on behalf of the client. Okay. So a rule that we were also taught by our lecturers was that always compile what we call a measuring list when you are about to do a taking off, when you are about to do even collects. Do a measuring list, because it will guide you to see what have you missed out in your calculations. You might miss out a step, and that might cost you marks. Okay. So first of all, on our list, we need to do site clearance. Okay. And then we need to do excavations. And then we need to do backfilling. Then we need to do, we are also told here that there is soft rock and then there is hard rock. And we are given a percentage for each, how much of a percentage we will get for hard rock. And then we also need to do risk of collapse. Risk of collapse is a situation whereby you have soil that is collapsible. I think maybe I can find a video to show you guys soil that's collapsible, and then I'll share that with you. Remember, health and safety is a very important topic in construction. When you do excavations and the soil is not stable, you might have to protect the workmen who are going to work inside the trench. So hence we do measure an item called risk of collapse. Let me just find a video that I'll play for you guys so that you have a visual of what we're talking about when we are talking about risk of collapse. Just bear with me. Let me share my screen here. Okay. Right. Okay. So,
who's in charge today? Huh? Who's in charge today? How you doing? I'm in the state of Oregon, OSHA. Looks like you got a little bit of a shoring problem going on.
I hope you guys can see.
Well, he can't be down there.
This is a safety.
How are you going to get him out? Shoring or what?
Safety video.
Jim, just don't look that way.
Let me just try to play that again. Just bear with me, guys.
Who's in charge today?
So,
who's in charge today?
This video, guys, shows.
How you doing? I'm in the state of Oregon, OSHA.
Okay.
Looks like you got a little bit of a shoring problem going on. Well, he can't be down there. Okay. How are you going to get him out?
but I'll show you
Want to
guys.
see
I'll
why
give
it
you a
can't be
link.
down there? That's why it can't be down there.
It's still sheets you gotta go in.
Okay, you got to get him out. And I hope you get him out soon. Example.
Ready, man? Go ahead, man.
So this is what we call shoring, guys. You're trying to hold your trench so that it doesn't collapse.
It's not holding at all. Pretty good system.
So this is your foundation trench.
Nothing.
But the soil
Well,
is loose.
maybe 5.
You see? It's failing.
You've got 3 inches of movement here.
Do we? See what, if that's it's going to shoot right off.
I think it's failed already. I think those are going to...
We haven't...
Okay, anyway. That's fine. Guys, I think what I'll do, I'll send you I'll just rather send you this thing, a proper video that you can watch. I'll send you a proper video that you can watch, and then we just take it from there. Now what I'd like us to do, guys, just trying to get back to my window now. Okay, and so okay, just bear with me, guys. This machine is new. It's a new machine, so still trying to get the hang of it. So guys, what I'm saying to you guys is this. So that's the reason for doing risk of collapse, because remember, soil once you disturb soil and you dig through it, it doesn't become it doesn't hold together anymore. It becomes a bit fragile, so it's prone to collapsibility. It can collapse. So if there's someone working in a trench that's 3 meters deep, there might be a possibility that that person may die. Let's say, for instance, let me draw a trench for you. Let's say this is a trench. Let's say from here to here is 3 meters, okay? And the person is here, working here. This person says 1.7 meters. If this soil over here collapses into the trench, this person is going to die, okay? So hence we need to protect the trench and put some supports on the side to keep the trench together. That's what we talk about when you talk about risk of collapse. It means protect the trench. I'll send you some literature on risk of collapse. Okay, that's one of the things we need to measure when it comes to excavation and earthworks. So we're still on our measuring list, and then we've got an item called keeping excavations free from water. Okay, that item deals with rain mostly, because you've dug an excavation. Tomorrow it rains, you come back, it's full of water. Excavation is full of water, so that's not a desirable from our point of view. It's not prescribed to work after it has rained, because you still need to dry up. It's not prescribed to do any concrete works when you've got a soggy field of mud type of trench. You need to let it dry. Okay guys, so that's our measuring list, and we need to cast concrete footings. Depending if there's a step in your foundation, if it's sloping or not, you might need to do a step foundation. You'll learn about that in technology. And then you need to do adjustments for cheese. Okay, I'll explain that when we get to it. I think now all of you are familiar with our descriptions. This description, you will use it up to your 4th year. You as a contractor need to state it so clear that there's no ambiguity. So we say clear the whole area of the site by digging up and removing rubbish, debris, vegetation, hedges, shrubs, and trees not exceeding 200 millimeter depth. Okay. So when they say clear the entire site, regardless of the shape of the site, guys, now you do not consider working space. You basically take from the footprint of your site, basically from your boundary, from where your site fence is, guys. Okay. So depending on what the instruction is, okay. So in this case, here is the site. Here's the entire site. It says clear entire site. So your dimensions for the entire site, your first dimension is 21,850. There it is. Second dimension, 30,200. That's your second dimension. Remember, site clearance as per standard system, we measure it in square meters. Okay. So you say length times breadth, then that's sorted. Then you take your dimensions and input it in your times in column over there. 21.85 times 30.20. That's your site clearance. Alternatively, guys, they can say to you, please don't clear the entire site. Maybe just clear around the footprint of your house. So meaning they just want you to clear around here where your house is going to be. That means you'll just need to allow 1.5 all round for your working space. Remember, if you're going to need to put scaffolding around here, you need to put materials and stuff like that around the perimeter of the building, then you need some space. You can't put it exactly on where the works are going to happen. So you need to allow 1.5 for your space around your house, guys. So you've got working space. You need to clear that one. Okay, fine. How do you do that? How you go about that? It's basically from your overall bigger length, you need to add 1.5 this side. Okay, then you need to add another 1.5 this side. So that gives you another dimension, and then you come to your other length 7150. You add the 1.5 and you add the 1.5. Those two dimensions will multiply out to get your square meterage of where your footprint is. But remember, on this one, you've got some sort of recess here. Okay, so this you will need to deduct this area over here, because when you said length times breadth, you also covered this whole section. So we don't do over measurements in quantity surveying. You need to deduct this area. So you need to deduct this 3.11 by 2 meters, because it's not part of the footprint of the house, guys. So that's how it plays out in terms of the dimensions. When you add 1.5 on both sides of 7.15, you get 10.15. When you add 1.5 times 2 at 11.17, the longest length, you get 14.17. You take that, you put it in your times in column, and then you need to deduct that area that is it's almost like a return or a recess, the L part of your drawing. This part, you need to deduct that. It's not part of, this is not a square, this is not a rectangle, so you cannot over measure that piece. Okay, guys, fine. And then guys, it's very imperative that you use your standard system when doing the works, okay? Because the rules of measuring this are in the standard system. So going to the next item, taking out and removing a tree that is exceeding 500 millimeter gap and not exceeding 1000 millimeter gap. That is also in your standard system. Remember, if a tree is a smaller tree and it doesn't, the girth of the tree doesn't exceed 200 millimeters, you won't measure it separately, because it will fall under your clear the whole site description, because it includes all trees that don't exceed 200 millimeter girth. Okay, guys, right? Now you might want to ask, how do you calculate the girth of a tree? Maybe it's worth me sharing with you guys how you would go about that. The formula for calculating the girth of a tree, there it is. The formula is girth is equal to pi times diameter. So you must look at the drawing and see what is the diameter of your tree. So basically, just go to your drawing. So basically, here's 60 millimeter diameter. So they say it's pi times diameter. So that's 60. So that's like 188 millimeter girth. So it doesn't exceed 200 millimeters. So this one falls under the first description that says clear sight and small trees not exceeding 200 millimeters. Okay, guys. But for instance, this tree now is 210 millimeters the diameter. So you get about 659 girth. Okay. So now the standard system tells you that you need to group your trees in exceeding it's either exceeding 200 millimeters, not exceeding 500, exceeding 500, not exceeding 1000. So this one clearly the girth does exceed, it's 659, so that exceeds 500 millimeters, guys. So don't forget the formulas. Calculating a girth of a tree, it's your pi times the diameter of your tree. Fine, okay, fine. And then you're going to cutting down and removing hedges. Hedges you can calculate in number or in meters. So already on the drawing you've got how many meters. It shows you in the description how many meters is your hedge. Okay, there it is, guys. So that's a simple one, simple enough in terms of that. And then we come to your collects. Okay, so that's site clearance done. We come to the collects. In the collects, first of all, we need to start with your biggest wall thickness. So your biggest wall thickness in the case of this drawing will be your 270 cavity wall. Okay, so when you do collects, guys, there in your module guide there is a very important principle that you are being taught over there, that you need to identify, write down, and then color. Okay, now maybe we would like to interrogate what that means. What that means, guys, is simple. It says you identify a dimension. Okay, there's two alternatives. I'll show you this one alternative, which is, I think, is the easier one for you guys. You see over here, you can identify, here is the dimension. Okay, you write it down. Okay, and then you must color this part in to say that you've already taken this dimension for your own checking. Okay, remember this side is equal to this side. Okay, so you're just gonna say times 2, 7150 times 2. Okay, so you can color this side also. Okay, and then you go to your longest length, which is 111170. You write it down, and it's also times 2, and you color it in. So you identify, you write it down, you color in, so that you don't duplicate your numbers, guys. Okay, after you've added up all of that, because the assumption is that we have a 4-cornered house, for us to get to a center line, what we do, we say 4, which is representing the 4 corners of the house, times 2. Okay, 2 we say 4 times 2 times half times 270. Okay, the 2 represents the 2 walls meeting at the corner. Okay, the half represents the center. Okay, so let me show you this way. Let me make a small sketch here. So if this is your wall, let me do a 4-corner house. If that's your wall, you've got one wall and another wall. You've got 2 walls meeting here. Okay, but remember, you want to get to the center of the wall. So the half stands for the center. Okay, and the 4 stands for the 4 corners. Okay, so you're gonna say 4 times 2 times half times 270, which is your cavity wall. That will give you 1080. Okay, that will give you 1080. You're gonna deduct the total of these 2 dimensions, 14300 and 22340. That will give you 36640 minus 10080. That will give you 35560. Okay, that you will take and input in your collects. That's going to be 35.56. That is your center line for your external brickwork. Okay, and that you will name collects A. Okay, that's your center line. And then you're going to go to your second biggest wall, which is 230 wall. And then you will just need to go and identify where your wall spans from in your 270 wall, in your 230 wall. So here is 7150. You just need to take away the 270 so that you are internal. You start from the internal to the internal. So 270 270 plus 270, I think that will give you 540. And then you say 7150 minus 540. That will give you the dimension for your 230 wall. Here it is. You must look at the annotation in your drawing. When it has a void, then you know that's a cavity wall. But when it's solid, you know that's a 230 wall, 220 wall. When it's smaller than this, you know that's a 110 wall. Okay, guys, that's fine. So there we have it. It's 6.61. So that's 7150 minus 270 minus 270, 660. Okay. Then you go to your 110 walls. In your 110 walls, it's also just very simple. You just take the dimensions. You identify a dimension, write it down. So let's first go for your 3.22. Which is your bath and kitchen wall. So here's your bath and kitchen wall. So it's just 3.11 plus the 110. That gives you 3.22. So you identify, you write it down, you color in that part that you've already done that part, and so on with all the walls. I won't explain all the walls because it's just taking dimensions and inputting them, guys. Okay, you're gonna add all the walls, all the dimensions of all the walls of your 110, and you're gonna get an answer. That's 10.71. Okay, this is still collects, guys, but that's collect C. Okay, that is B for your 230. That's A. Okay, this thing you're gonna use it when you are doing your actual taking off. Okay, now let's show you how easy it is. Now we don't have to go refer back to the drawing. Okay, because we already have our collects. Okay, and in our collects we already stated the size of our footing. It's 750 by 230 for your 270, and then it's 700 by 230 for your 230, and then it's 600 by 230 on your 110 wall. Okay, so what do we do? First item, we need to do excavations. Okay, as I was saying again, you need to describe to the contractor what they must do. Okay, so you must learn to practice doing descriptions. So you're going to tell the contractor, excavate in pickable material for surface trenches not exceeding 2 meters deep from ground level, and extra over trenches and holes excavations in soft rock. If they've provided you a percentage, they'll give you a percentage, say 10%. Okay, that's how you would annotate that. And then you say ditto, but in hard rock, and then you give the percentage for the hard rock. Okay, and then say and earth filling obtained from excavations for backfilling to trenches and holes. Okay, now the reason we do a backfill whilst we're doing also an excavation for the same dimensions is gonna be clear when we get to measuring our concrete and measuring our brickwork. You will see that we know that we have dug the excavation and put the filling back, but we are gonna remove it back as we go on our measurements. Okay, so after you've done that calculation, you need to go to A and take the center line for A, that's 35.56, and come and write that you have taken that reference, that this is from A, this is from your 270 cavity wall, and then you're gonna multiply it with the depth of your trench. Okay, now how do you get the depth of your trench? You go to your drawing. Okay, in your drawing tells you that here is national ground level, guys, and then they give you, you've got 570. Okay, you've got 570 plus 230, which is your thickness. That gives you 800. Okay, now that is the depth of your excavation. Okay, guys, I hope that is clear. So it's gonna be 35.56, and then you're gonna come to A to find your information. If you come here to A, it gives you, at A it gives you that the width of your footing is 750. Already your drawing tells you your depth is 800. So it's 35.56 times 0.75 times 0.8. Okay, and then that is from A. And then you come to B for your 230 wall. Same thing. You take your center line over there, and here we've been told that our width is 0.7. Okay, there you are. 6.6 times 0.7 times 0.8, that is your depth. Okay, then you go to your 110 wall. You take your center line as specified and take your width, which is 600. That's 10.71 times 0.6 times 0.8. That's your depth. And all these cubes apply to also here. The answer you get from A, you need to multiply out with 10% to get the cubes of the cubic meters of your soft rock. And the answer from A, you need to multiply over here with your hard rock, okay, to get the answer of how much is the percent of your hard rock. So you can add up, calculate all of this out, and get a cubic meter quantity and put it here, that quantity, multiply it with the calculator to get your percentage and put the answer there. Okay, that is for your rock excavation. This information will be taken and put into what we call a bill of quantities for tendering purposes. That will be given to your contracted price. Okay, guys, and the extra over backfilling, we're taking that same soil, backfilling it, because we are gonna show you in a later stage how we're gonna take out and calculate how much material to cut off site to the dumping site. Okay, and then we need to do risk of collapse. As I was saying to you, that we need to protect our workmen, so we need to protect the sides of our excavation, that it must not collapse. We need to put mechanisms, either machinery or either timber materials, to make sure that the soil, if we've got an open trench like this, the soil doesn't collapse and then the person in the middle gets buried. Okay, so we need to find ways of making sure that the trenches do not collapse since we have opened a void in it. Okay, guys, and then you will just use your center line, which is 35.56 from A. Okay, this is the example again that your collections helps you to measure out different items of work. So even your risk of collapse, you're gonna use the same. You're gonna use your center lines. Okay, and remember now you are shoring both sides of your trench. Hence, you're gonna see that it has two. Okay, so let's say this is your timber planking. That is your trench. Okay, and that is your jack. You're gonna do something like this. So this thing goes all the way across your trench. Okay, this thing goes all the way along, because what we don't want your person who's working here that the soil must collapse into him. Okay, so we need to make sure we put in even if it's a steel shoring cage into this, so that this person here is protected against the collapse of the soil. Okay, I'm hoping this makes it a bit more clear. Okay, this is your trench, person is working there. Okay, so we are ensuring that the soil doesn't collapse into the trench, right? So again, take a center line times the depth of your trench, which is 0.8, times two sides, this side and that side. Okay, same thing on your excavations for your 230 wall, 6.61 times the depth and both sides. So guys, I'm thinking that as long as you grasp the concept, the principle behind these activities, then you won't have issues with this, guys. Okay, so just try and grasp the principle that first get the center line. Once you get your collects and get your center lines for all of them, you'll be able to calculate other items like excavations, concrete, and etc. Here's your concrete, same thing. Your concrete, we know that it's from our collects, it tells you it's a 750 wide by 230 thick concrete footing. So you just transfer this information into here. We've got a 10 MPa, let's say 19 mil stone unreinforced concrete footing cast against excavated surfaces. So you go take from A, which is your collects again, 35.56 times 0.75 times 0.23. You do the same even for 230 wall and 110 wall. Okay, guys. I don't want to go through the entire activity. I'll just implore you to maybe I'll send you the pages to this book so that you can just browse through the book and maybe practice on it. The question that I got that was maybe a challenge to you guys was the adjustments. So for the sake of this, I'm not going to explain further the concrete because it's self-explanatory. You just take the center line, times it by the width and the thickness of your footing. So you're going to do the same thing for B and for C. Okay, because you've got it on your collects. On your collects it says 230 wall on 700 by 230 millimeter footing. So you just take that information and input it there, and then you know you're done. Okay, now let me read that concrete so that you can understand the backfilling part that I spoke about. So when we come to our footing, we say 10 MPa 19 mil stone unreinforced concrete cast against excavated surfaces, and then we send and deduct. Okay, we're gonna deduct now backfilling to trenches and holes as described before. Okay, and then we're gonna say and extra over excavations for cutting away surplus material from site to dumping site selected by contractor. What do we mean about this? Okay, remember we had a trench, right? This was our trench. We excavated for this trench. This trench is 800 millimeters high let's say 750 wide, and then it's 35.56 long. Okay, so what we did in our first description, we excavated this. Remember, we excavated all of this in our description here. Remember, and then we said and extra overall for soft rock, and then also for hard rock, and then we said backfilling. We said earth filling obtained from excavations, backfilling to trenches. So we backfilled back the same cubic amount that we excavated. But now, since now we're gonna cast concrete footing here, okay, we're casting that concrete footing over there. Okay, so while we are calculating the footing, we are also saying now let's also deduct that soil we put back. That soil must go to cut away. Okay, that extra soil that we put back after we said excavate and then we said backfill again, now we are saying deduct that backfill, right? Deduct that backfill as before described, and extra over for cutting it away. We are taking that soil away, but that soil, the quantity of that soil represents the quantity of the concrete we are putting in our footing. Okay, you're gonna see when we get to the wall that when we get to the wall, we are also gonna deduct the space that is occupied by the wall, and we're only gonna leave this side that we still needed to just leave. We're gonna leave it. We're not gonna cut away this one. Okay, the brown part here, guys, we won't cut it away, but we'll take out where the wall is positioned, and we will take out the soil here where the wall occupies and where the footing occupies. But that part I'm gonna get to it when I get to the wall. Okay, but now I'm taking this one for the footing and cutting it away. Okay, that's fine. Let's go ahead. So there are the dimensions. Just take from each type of wall type and just put the concrete according to the specification of it. That's fine. And then we go to foundation brickwork. Okay, so it's a 270 cavity wall in foundation brickwork. Now what we usually say, as per maybe a norm in industry, we say our foundation usually our foundation wall usually ends at DPC level. Okay, but now you'll find that in this drawing it says that your foundation wall ends at finished floor level. Okay, but I would like you for this exercise to go only up until DPC level, which is this one. Okay, so all you need to do is to take the level here, okay, which is let's say 100,000 minus then you're gonna minus the thickness of your slab, which is gonna be 100. That's gonna take you to your DPC. Okay, and then you take that answer you get over there and minus 99625. Then you're gonna get the difference in height. Okay, maybe let me rather do it for you so that it's easier. So you're gonna say 100,000 minus 100. Okay, sorry man, the drawing size is 80 thick, the slab is 80 thick, so don't mind me. I'm just going with the norm. So we're gonna deduct 80. Okay, that takes me here to DPC level, but I want my height of the brick wall from here to here, so I'm gonna say minus 99625. that gives me 295. So from DPC to ground level is 295, guys. Okay, so 295 plus 570 gives me 865. Okay, so that's my depth. Okay, I hope that's clear. 865, that's my depth. Okay, right. But in terms of the exercise in the book, because they gave me another, like they did another assumption, it will be different. Okay, but that's fine. Let's just work with what they've given us anyway. So we'll work with 0.84, which is from the exercise in the book. Okay. From there, if we use we're gonna say 270 cavity wall, including wire ties and filled solids with unreinforced concrete, 10 MPa. Yeah. So that is a description for your 270 cavity wall. And then you go again to your center line, 35.56. It will always be the same, times 0.84, which is your depth. Okay. Do the same for your 230 wall, same for your 110 wall. And then this is where it becomes interesting. Okay. Now we need to deduct the backfilling. Okay. To deduct the backfilling. Remember the drawing I did for you. Remember this drawing I did for you here. Now we are deducting this part because now we have built our brick wall in foundations. So we're gonna say 35.56, which is our center line, divided by 0.27, which is the width of my wall, of my 270 cavity wall, times 0.8, which is my 0.84, which is my height of my foundation brick wall. Okay, to ground level. Okay, remember it must come to ground level. Well, what you must backfill there. Okay, so okay, no, just bear with me, guys. Okay, this will be the height over here, guys, will be 0.57. Okay, that's my mistake. Remember, we're only taking we are deducting only up until ground level, because that's where our backfill will end. So the depth here will be 0.57. So just insert that over there. Okay. So for all of them, it's gonna be 0.57. Gonna insert it there. 0.57. Insert over there. Insert. Okay. So what we are doing, we are deducting the wall. Okay, remember we had said backfill. So now we have built a wall here. So let's take away that soil that occupies the space for the wall. So deduct backfilling to trenches as before, and extra over for cutting away. Okay, so now it means that the soil that is left over here will be the soil for cutaway. The soil that is left over here is the soil for backfilling, and the soil that occupied the space for the footing and for the wall is gonna go to cutaway. Okay, but that will be done by someone who's gonna compile the bill of quantities. Okay, here's the important part that I thought you guys were saying you are interested in. Is the adjustments. Okay, the adjustments are done because we cannot over measure, guys. We cannot over measure because excavations also cost money. Okay, it costs money to excavate and do something. So let's take for instance this wall. This is a 270 cavity wall. Okay, it's the one that is represented by 35.56 meters long. Okay, that's the center line for it. Now this wall has a wall butting against each that is connected to it, which is your 230 wall. Okay, now remember there is a trench over here. That trench was for the foundation footing for your 270 wall. Now your 230 wall comes all the way across to butt against your 270 wall. So when you calculate the excavation for your 230 wall, this part where it comes closer has already been excavated. Let me put it in yellow. This part has already been excavated, guys, when you were doing the excavation for your 270. Okay, this part had already been excavated, all of this. So now you cannot say when we are calculating excavation from here to here and excavate this part, because it's already this part has already been excavated, so you need to deduct this part. Hence we are saying deduct T's, okay, and then you add wall ends, okay. Same situation that is happening between your 270 and 110 wall, okay. There was already an excavation here, okay, for your 270 wall. Now here comes your 110 wall butting against your 270, okay. Now this part has already been excavated, guys. You cannot re-excavate this part, but this one has not been excavated, okay. So you need to deduct this part because it's already been measured when you are excavating this one, okay. Same thing that is happening over here, where your 110 comes to your 110 and makes a T, okay. You've already excavated this part. You can excavate this piece again. You can only excavate from here to here, okay. Let me show you in the drawing what we mean about it forming a T, okay. This is what we mean, guys. Here's your 230 wall, and it's coming straight against your 270 wall. It's forming a T over here, okay. And also this side, here's your 270. Here it's forming a T with your 230 again, okay. So there is already a trench here. You can't re-excavate that part, okay. Here is where a 110 also meets a 270 at a T. So you can excavate there. Here is where a 230 meets a 110. You can't excavate there. Here's a 110 that meets a 110. So this schematic represents the part where it butts against another wall that has been excavated already, okay. I hope this is understandable. So what we do in order for us to get what is the thickness of our deduct, because it's only this piece that we must deduct, okay. So what we say, we're gonna say 750, which is the width of our 270 wall, okay. We're gonna say 750, okay. We're gonna say 750 minus 270, okay. That's gonna give us 480, okay. And then 480 divided by 2 is gonna give us 240. So let me show you in another form what I mean. Here's a 270. Here's 750, okay. What we are saying is this, that this part from here to here is 240, from here to here is 240, okay. 240 plus 240 plus 270 gives you 750, okay. And that translates here, that from here to here is 240. So what we're gonna do, we're gonna say 240 times the width of our trench of the wall of your 230 that is butting against the 270. 240 multiplied by 700 times the depth of your trench, okay. That is it, guys, okay. So just grasp how we calculate when you are going to deduct for a T, that you need to say, so for instance, where your 230 comes against your 110, you're gonna say you're gonna say 700 minus 230, okay. So here's 700 minus 230. Let me write it a bit clear. 700, okay. 700 minus 230, and then you divide it by 2, and then you get 235. So from here to here is 235 also, okay. And from here to here is 235, okay. 235 plus 230 plus 235 gives you 700 wide trench, okay. So we're gonna say 235 times 600, which is the width of our 110. Our 110 trench is 600, okay. 600 by 235 by the depth of our trench, okay, because we're deducting for the trench, okay, because we are over measuring if we're gonna take this right through. Okay, I think, guys, that was what you guys were having maybe an issue with. Now what is important is that you go and identify in your drawing how many of the 230 to 2 that are going to against 270. So in this drawing we had 2, okay, and here they are, this side and this side. So you have 230 versus 270 T's, okay. So that calculation we're gonna say times 2 that we're gonna deduct, okay, and then your 230 versus 110, you're gonna have 1 only because here it is only 1, and then your 110 to 270, that's 1 and that's 2, okay. So there it is, okay, and then you're gonna have a 110 to 110 fighting against each other, and then there it is, here's 1 and here's 2, okay. So that's how you adjust, okay, for your excavations. And then you also, that adjustment is gonna also include excavations, soft rock, hard rock, okay. And then you're gonna set and deduct backfilling to trenches as before, and then you're gonna still need to go and deduct the risk of collapse to that part, okay. Now the risk of collapse is a pretty simple understanding, okay. Remember, risk of collapse is just in meters. Just ask yourself, if you look at this, if you look at the 230 versus 270 wall, you won't do risk of collapse in this part that we have deducted, okay, because it's already been measured. You can't measure it again. You're going to deduct this risk of collapse that is over here, okay, because it's already been measured under another item, okay. So that's why you're going to have 0.7, which is going to be the width of this trench where you have deducted, times 0.84, which is going to be the depth of your trench, okay. I hope that's clear, okay. So same thing applies to all the other walls where they butt against each other, and then you're going to go deduct your concrete footing, because remember, we are adjusting. We are not going to do a double measurement for concrete also here, because we're taking out the soil. We're also going to take out that piece of concrete we put there. So it's still going to be the same dimensions. The difference in this case is going to be the thickness, which is going to be the thickness of your footing, okay, guys. So the dimensions that we are using here in the excavations, you're going to transfer them to your 10 MPa. Difference, you're going to say 0.7 by 0.24, which is 0.24 is from here to here, by 0.7 by the thickness of your footing, which is 230. Okay, you're going to deduct that. That you will do for also the other wall adjustments, okay. So that will be the end of adjustments, guys, okay. And then you've got your superstructure brickwork, which should be primarily very easy because you've got your lengths and your heights. This one, I don't foresee that you will have a problem with this one, but you still use your center line. So center line times your height, guys, okay. So center line times your height. So you're gonna take from A, it's gonna be 35.56 times 2.64, okay. And then you will also go to your 230 wall, 6.61 times 2.64, then to your 110 wall also. But maybe I should show you the rationale behind the other dimensions over there. Let's see. I'll show you the rationale now. Okay, here's the rationale, guys, for the other dimensions, okay. So it's your 2.6 as per what you've been given on your drawing. So let's go to your drawing. So here's 2.6 on your drawing. That's your height. Okay. That's your height above floor level. Okay, that's 2.6. So you will just add this floor 30 millimeter, which is the screed, and then this should be maybe a tile or underfelt. That takes you to 2.636. Okay, that takes you to 2.64. That's your height. Okay, and then your beam filling is going to be 3 courses. Okay, 3 courses of your beam filling. That's 3 times 85. That's 255. Okay, and then you're going to do it in selected places. You're going to do your beam filling. That is this is for cables. Okay, and then you're gonna come to 230 wall, which is, I'm assuming, is gonna be a firewall. And you're also gonna do, and remember, when you do your cables, it's gonna be half base times height. Okay, remember there's a L section there in front. Okay, hence we are doing 4.04 and separating it, guys. Okay, and then yeah, we've got your 110. Same. So what I'll do, I'll give you the page numbers of this book, then you can browse through the other ones. I was just thinking that maybe the biggest items you might have problems with should be maybe the adjustments, but maybe drop me a comment and subscribe to the channel. Drop me a comment and ask some questions. If you want me to focus in a certain part that you think you have challenges on, please tell me in the comments, and then I'll do so. Thanks, guys.